Okay, so there were some questions about using the vector addition simulator, so I wanted to create a quick video just to show you how you can use this in aiding you with your quiz. So the quiz, of course, is down here, and when you click on the description for it, I say to explicitly use the Explore 2D option to help you. So when you click on that, I'll go ahead and erase this. I'd been playing around with it earlier. But you're free to pick out vectors and put them on there. And notice when you click on them, whichever vector you are clicked on is the one that's being described up here. And you have the magnitude, the direction, and then you have the x and y components. So in order to determine vector addition, if you were to actually do this graphically, you would use what is known as the tail to tip method, where you line vectors up tail to tip, and then the resulting vector, the sum, if you click sum, you can see would be the same as a single vector running from the origin to your final point. And that's true even if you have 3, 4, 5, 6, 7, 8, 1,000. It doesn't really matter how many vectors you have. The tail to tip method will always work. Tail to tip, tail to tip, tail to tip. But we're going to focus on just the two vectors rather than 3 right now. So when you select them, even if you don't put them together in fancy tail to tip method, you can throw them anywhere on here. And if you click on the sum, it'll tell you what the sum is as far as direction. Magnitude, direction, and the two components. You can move these any way you'd like. You might have to tweak them if you're trying to get an exact distance, because these are not anything you can edit. So you just have to play with it till you get to the desired magnitude and direction, or the desired components. And then move over to the next one, and you can tweak that as well. And your result is still going to be from this sum piece. Hopefully that helps. For example, just if I wanted to take the vector with components x3, let's see, x3 and y5, so let me try 3, 5 and see if that's something I can make. There, 3, 5, and -2, -6. If I wanted to add these two vectors together, it looks kind of silly, but I can certainly do that. That would be the vector 5.8 at 59 degrees, and the vector 6.3 at -108.4 degrees. And their sum would be 1.4 at -45 degrees, and the components would be 1, -1. So that's all there really is to it. If you have further questions, be sure to reach out to me through email or ask in the discussion board. Best of luck on that quiz.